Hi, welcome to this episode of the Data Beat. My name is Puneet Sachdeva, and today I will talk about as to how the compute type and the underlying chip architecture makes a difference, especially when it comes to data processing using Databricks. As the host of the Data Beat, my aim is to bring the latest from the world of data analytics. Like always, it's a good idea to like the video, subscribe to the channel, and click the bell icon to get notified about the new shows. Well, the performance of a Spark job depends upon balance of data distribution, underlying compute, available memory, and also the manner in which the code has been written. Despite this, I have observed that majority of the engineers try to increase the number of nodes in the cluster and troubleshoot, all while rerunning the job over and over again. Now, what if I told you that besides the number of nodes in the cluster, it's also the type of node which also matters? Talking about Azure Databricks, where Databricks provides an option to choose the worker types from general purpose compute, which includes mainly the DV series 2 and 3 versions, DS series 2 and 3 version series, to memory optimized D series, DSV series 2 and 3, EAS version 4, ES series, and EV series. Now it doesn't end there. There are storage optimized compute as well, which includes LS, LSV2, and to top it all, you have the GPU based compute, which includes NC, NCS, NCA series. Now, what does it all mean? It's quite a handful. I would certainly like to know which one do you use for your compute and why. Please take a pause and share it with me in the comment section. Alright, coming to the fact that Intel is among the largest players in the data center compute market. It clocked almost $21 billion in the Q4 of 2021, just from the data center segment. It's not a surprise that Intel and Databricks are partners. And what that partnership means for us is what I'm going to share today. Well, you have all been using the Intel processors on your personal devices and other things. But looking at its power in the data center actually takes it to the whole new level. Intel and Databricks recently published the benchmarks as to how the TPC queries fare on the compute powered by Intel's third generation Xeon scalable processors. Now, for those who are new to TPC, TPC is a non-profit corporation which is focused on developing data-centric benchmark, mainly the standards, and disseminating the objective and verifiable data to the industry. Members of this organization include Actian, Alibaba, AMD, Cisco, Dell, Fujitsu, HP, Hitachi, Huawei, IBM, Intel, Lenovo, Microsoft, and Nvidia. There are more players. To know more about it, visit https://tpc.org. Now, coming to Intel and Databricks, it is claimed that by using Intel Xeon third generation scalable processors on Databricks, one gets 3 times the performance benefits and more than 6.5 times of the speed up. Well, it's not just the magic of the compute. Databricks Photon also has a role to play. Databricks Photon is a next generation query engine for the lakehouse. Under the hood, it is vectorized engine which is written in C++. The magic happens when they meet the Intel generation third generation of the Intel Xeon scalable processors, which includes Intel's advanced vector extensions. Well, what does that mean? Well, I can say that much that I tried decoding it all and I figured out that I need to get that engineering book for digital electronics and go through the x86 architecture again. Well, jokes apart, Intel's advanced vector extensions is a set of instructions for doing single instruction multiple data or SIMD operations on Intel architecture CPU. These instructions extend previous SIMD offerings by including 5112 bits or more SIMD registers, improving instructions to include up to 4 operands, and aligning the memory requirements for the operands and making it more scalable for future architectures. Well, I was not joking. You should have read the x86 architecture thoroughly. Now, when Databricks Photon and Intel third generation Xeon with advanced vector extensions meet, the magic happens. And as per the benchmarks, the baseline stands somewhere like with Databricks runtime 10.3 without the Photon on Intel's first generation of Xeon processor, the TPC standard for data systems, TPC DS, the time to process 1 terabyte of data was about 2,265 seconds and costs around $14. With Photon enabled on Intel's, again, the first generation Xeon processor, the same workload took 645 seconds to complete and costs around $7. That's almost 3.5 times faster and 2 times cheaper than the baseline. And with the Intel third generation of Xeon processors, with Databricks 10.3 and Photon enabled, the 1 terabyte TPC DS workload took just 334 seconds to complete and costs about $4.78. Now that's more than 6.7 times faster and 3 times cheaper compared to the baseline. That's all great. Now how you can benefit from all this? Ensure that you are on Databricks runtime 10.3. Have Photon enabled and use compute which has the Intel Xeon third generation processor. As per Intel and Microsoft reference, Intel Xeon third generation processors are available in DV5, DSV5, EV5, ESV5, DDV5, DDSV5, EDV4, EDSV5, EBSV5 and EBSDV5 compute options. I'll leave that information in the description somewhere. Now, next time that you need that extra burst of performance, ensure that you use the right compute, the right number of nodes, the right amount of memory, and of course, write the right code. In this episode, we talk about how the compute type and underlying chip architecture makes a difference when it comes to data processing using Databricks. Feel free to reach out to me through your comments. I'm eager to learn from your experience. My intent is mainly to bring the concepts and simplify it for you. If this helped you to build some understanding, then I think it's a good idea to like the video, subscribe to the channel, and share it on LinkedIn or wherever your peer group is. So until we meet next time, keep the beat flowing.